All right, hello YouTube fam. We have a special guest. We have Ava Romero with us. What's up, Romero? Oh, okay. But yeah. In a little bit, she's gonna tell us all about her adventures at Yale and all that good stuff. And uh, okay, I'll stop. All right, so here we go, guys. Composite argument properties for cosine A minus B. At first glance, you're looking at it, and you're like, what the heck do we want? What do we want? I don't understand. And it says here, well, I could just give you the formula for cosine A minus B. I don't want you guys to turn into robots. We will drive this formula and see what's up. And you still don't know, like, I don't know what you want, Chop. So I'm going to write, what do we want? And I'm talking about math life, right? Not like, what do we want, like chocolate cake or something like that. What do we want? We want a quote unquote formula for cosine of A minus B, where A minus B is an argument, and A is just some angle and B is just some other angle. So tell me if this looks familiar to you. We're going to derive this. I don't want to give you, of course, I do give you the formula. It's right here. But I don't want to just give it to you. I don't want to be that teacher that just says, let's just use it. We are going to use it. If you don't understand the formula, that is okay. As long as you know how to use it. We're not going to ask you to derive it, but I want you to see that all these formulas come from somewhere. Does that make sense? Okay, so let's exaggerate quadrant 1 of the unit circle. So here's my quadrant 1, and here's that unit circle part. See? And if you have colored pencils, this is the best place for colored pencils. I'm going to call angle A, this segment. This is going to be my segment A, and I'm going to call this guy angle A. So if that's angle A, this coordinate right here on the unit circle, that's just cosine of A and sine of A for the y value. Do you guys agree? I'm going to use a different color. I'm going to use green. And I'm going to say from here to here, I'm going to say that this is angle B. So this coordinate here is cosine of B, sine of B. Have I lost anyone? Okay. This in between the blue segment and the green segment, do you agree that is the difference of angle A and angle B? Okay. We don't need that just yet. Just put that on the side block for now. All right. I want you guys to notice, and let me write this over here like this. A minus B. I want you guys to notice that if I were to draw a triangle right here from this vertice to this vertice, so I just need another one like right perpendicular, boom, and there's my right angle. See? And if I connect these two dots, I have a triangle like so. This is just some horizontal displacement. Horizontal displacement. Just the distance between this corner and that corner. And this is just some vertical displacement or distance. Are we okay? I haven't done anything crazy, have I? All right. If I told you I want you to calculate this distance here of this hypotenuse, or I guess make a relationship, we could use Pythagorean theorem. We can use Pythagorean theorem, guys. So like, sine A squared plus B squared equals C squared, where the hypotenuse is the C squared. I'm going to call it D because D usually stands for distance. So I'm going to call that D. And this horizontal displacement is nothing more than this x value minus this x value. Chop, I don't know what that x value is. Yeah, it is. It's this guy. See? Because whatever that is. So this is just cosine B minus cosine A. Do you guys agree with that? Okay. Look at the vertical displacement. The vertical displacement is the y value, or the top y value minus the bottom y value. Do you guys see that? So what's the top y value? So I'm going to write vertical displacement equals sine A minus what? What's this bottom y value? Sine B. Good job, guys. You guys are using logic. And if I do Pythagorean theorem, remember Pythagorean theorem, a squared plus b squared equals c squared. If I do Pythagorean theorem, I can make a statement like this. D squared, I'm going to write, instead of saying a squared plus b squared equals c squared, I'm putting the c squared first, but we called it d. So I wrote d squared equals this guy here, squared, because that is that leg of that right triangle. So cosine b minus cosine a squared plus, and then the vertical displacement. Sine A minus sine B squared. Have I confused anyone? All right, now we're just gonna I'm just gonna choose a general color. My favorite color is red to write on this thing. I'm just gonna expand it, guys, just with algebra. So D squared equals cosine B times cosine B is cosine squared B. All I'm doing is expanding it, guys. That's squared there, and that's squared there. And then I'm going to do cosine B times cosine A. That's going to be minus cosine A cosine B. But then you're going to have two of them, right? Because then you do cosine A times cosine B. So I'll put a 2 there. And then cosine A times cosine A plus cosine squared A. Do you guys know what I'm doing? You can say no if you don't. No? Okay. Okay, don't write this down. If you know what I'm doing, don't write this down. Even if you don't know what I'm doing, don't write this down because I want you to take this in. All I did was this, guys. You see that squared? All I did was this. I just did cosine B minus cosine A times cosine B minus cosine A. And I know I need to make a habit of putting the arguments in there. And there it is. That's what cosine B times cosine A squared is. Cosine B times cosine B, cosine squared B. Cosine B times cosine A minus cosine A cosine B. And then you go to the next one. Cosine B times cosine A minus cosine A cosine B. And then cosine A times cosine A minus 2. Negative times positive times a negative. Yeah, minus. Minus 2 cosine squared A. Oh, negative times a negative plus. I don't know why I said that. See, there it is. Cosine squared minus 2 cosine A cosine B plus 2 cosine squared. And that's what I have. Plus cosine squared. Why did I write 2? It's just cosine times cosine. Sorry about that, guys. Does that make sense? Okay. Sorry, I'm going really fast. I'll slow down. I haven't finished. I still need this guy. So look, I'm going to do it again. Plus, that plus is this plus. Sine A times sine A, that is sine squared A. And I'm going to go sine A times sine B, and that's sine A sine B, but I'm going to have how many of them? 2 sine A sine B. And then negative sine B times negative sine B, that is going to be plus sine squared B. You put the square after the n because it's sine that's being squared, not the B, not the angle. Are we still okay? Remember, you're doing it right? Okay. You're not saying like, dang, why did I come in here? All right, check it out, guys. This guy right here, cosine squared B plus sine squared B. They have the same argument. What do we say about cosine squared plus sine squared if it's the same argument? 1. That's the Valentine's formula. So I'm going to write D squared equals, and then look right here in the middle. I'm going to change the color so you guys can see it easily. Look at that one. Cosine squared A plus sine squared A. It has the same argument. That's also another 1. So what's 1 plus 1? So I'm going to have 2 minus 2 cosine A cosine B minus 2 sine A sine B. Okay. We're done with that part. We're halfway. We're almost done. I know, guys. Now what we're going to do, and I suck at drawing. I'll try to draw it as best as I can. I'm going to move or translate this right there. It's going to be right on top. The green segment's going to be right on top of the x-axis. And I'm gonna try to hold everything the same. You know what I mean? Do you guys see what I'm talking about? So I'm going to try to hold everything the same. Remember, that's still a unit circle. So I'm going to exaggerate the unit circle. So here I am. I'm going to do the same thing again. Quadrant 1, exaggerate quadrant 1. I'm going to try my best to make it the same. All right, so here's my green. That green segment down there is this one. Oh, I can already tell it's not the same because my scale is totally different. This one's way bigger. That's fine. And here it is, my blue segment right here. And this one right here is this was a purple, and that was A minus B. And because this is a unit circle, this coordinate right there is 1, comma 0. And segment D is still this one right here. Let me see. Yeah, my triangle sucks. Okay, guys, these triangles are supposed to be the same. Oh, man. These triangles are supposed to be the same. Same triangle as... They're supposed to be the same, but my drawing sucks, so I'm going to put not to scale. Not to scale. But they're supposed to be the same, guys. Are we okay? All right. Now check it out. This is still the distance, D, this guy right here. And I'm doing Pythagorean theorem again. But this time, notice that I emphasize angle A minus B, which is this guy right here. The difference between the green and the blue. It's the same segment, guys. So this corner, this segment here, is cosine of A minus B. That's how I get that x coordinate. And that y coordinate is sine of A minus B. Are we still okay, guys? Okay, check this out. I'm doing Pythagorean theorem again. The same deal. So I need the horizontal displacement. So this guy right here, I'm going to say horizontal displacement is coordinate 1. So 1 minus, and then this x value is this x value, cosine of A minus B. And that's it. I don't know why I put parentheses. I'm not squaring anything. That's a horizontal displacement. This vertical displacement, and I guess I'll color code it or try to color code it. Let me use purple. No. I don't want to use purple. Can I use blue? This vertical displacement, did I call it horizontal? That's a vertical. That vertical displacement is the top, sine A minus B, minus the bottom y value. That bottom y value is 0. So what am I going to do again, guys? Pythagorean theorem. Child, but we already did Pythagorean theorem. Yeah, but not for this one. And then we're going to set those two d's equal to each other. It's going to be so beautiful. Look at this. So I'm going to write d squared, a squared plus b squared equals c squared, or d squared, right? That's the hypotenuse of this triangle, equals my horizontal displacement squared, 1 minus cosine of a minus b, close squared, plus your vertical displacement squared, sine of a minus b, close, minus 0. I guess if you want to see that, close it squared. I'm going to expand it. Look how beautiful this is going to be, guys. D squared equals, what's 1 times 1? 1. And then 1 times cosine A minus B is cosine A minus B, but I'm going to have how many of them? So I'm going to write minus 2 cosine of A minus B. And then cosine A minus B, negative times another negative cosine A minus B. Negative times a negative is a positive cosine squared of A minus B. And then anything minus 0 is itself. So I'm just going to square that. So plus sine squared of A minus B. So catch up to here. And look at this, guys. This right here, cosine squared of A minus B plus sine squared of A minus B, that is just 1. And then look, I already have a 1 up here. So what's 1 plus 1? 2. So I have this. D squared equals 2 minus 2 cosine A minus B. And we're about to reach the magic. Look how cool this is. I think this is just so beautiful. Look at all this beautiful math we've done. So check it out. Do you agree that this d squared is the same as this d squared? Well, yeah, because it's the same triangle. I know my drawings suck. I got a D in art, guys. I'm sorry. But it's the same triangle, guys. So that means that I can set this expression equal to this expression, which is exactly what I'm going to do. Do you remember this, Romero? Did we do this with you guys? I don't remember if we did or not. 2 minus 2 cosine A minus B close equals 2 minus, let me zoom out so I can see. 2 cosine A cosine B minus 2 sine A sine B. Did you do pre-calc through Zoom, Romero? Or no? Okay. All right, guys, check it out. We're done. What are we looking for? We're looking for cosine A minus B. So the first thing I'm going to do, I need to get cosine A by minus B by itself. So I'm going to subtract 2. I need to get rid of that 2. Whatever I do to one side, I do to the other. So those 2's just go away. And now I have this. Negative 2 cosine A, cosine A minus B equals negative 2 cosine A cosine B minus 2 sine A sine B. And then the last move to get cosine A minus B by itself is divide by negative 2. Whatever you do to one side, you do to all of them. So when I do that, look what you get. Cosine of A minus B equals cosine A, cosine B. Negative divided by negative is a positive, plus sine A, sine B. Is that what they have down there? Yeah, look at that. That's what they have as a formula. Isn't that cool, guys, that we derived this from scratch using the unit circle? Or you don't think that's cool? Yeah, it's cool. Look at all this beautiful math. Take a picture and send it to your parents. And say, look what I'm learning. I think that's so cool. All right. If you did not understand that, if you weren't able to hang through any of that, relax. All you got to be able to do is use it. That's all you got to be able to do. So, Chop, how do I use it? Like this. You see this expression? Look at example 1. It wants a linear combination of cosine and sine. Chop, I have no idea what this means. That means that they want it to look like this. A cosine theta plus B sine theta. Linear combination. See, I'm adding, and I see a cosine and I see a sine. And that's what we did right before we ended the fall semester. So that's what they want. So we're going to use our property, Chop. But how is that going to get us that? Well, look, this has a cosine and this has a sine. And one of those letters is going to be a constant. So it's going to be a number. So, Chop, I don't understand what you're talking about. Well, look at this. I'm going to put a bracket like this. And I'm going to put that theta to an A. And I'm going to put that 23 to a B. So here we go. 7 bracket. And all I care about is using this formula, guys. So that theta is like an A, that 23 is like a B. So I'm going to write, what am I going to write? You guys help me. I'm going to write cosine theta. Am I done? No, not minus 23. Look, it says cosine A. I'm writing the right expression. I put cosine 23. Yeah, don't be scared. Cosine theta, cosine 23. They should be putting parentheses around your arguments, but they don't do that. They don't. And then I'm gonna put what? Plus. That plus is this plus. And then I put sine theta, sine 23. Perfect. And then close it with the bracket, and I'm gonna distribute the 7. I'm gonna write the cosine 23 first, guys, because that's a constant. So I'm going to write it like this. 7 cosine 23 degrees cosine theta plus 7 sine 23 degrees sine theta. I just distributed the 7. Take your calculator. Make sure you're in degree mode. So here we go. I'm taking my calculator. I'm going to put my mode, push mode, and make sure that it's in degree. And I'm going to go 7 cosine 23, push enter, 6.44353. Let me see if I can remember that. 6.44353. I got it. I think I got it. Cosine theta, that's this one right here, plus, and do 7 sine 23. 7 sine 23. And 2.73511 if it's truncated. 2.735, I already forgot. 73511 sine theta. And there it is, guys. And it says here, it doesn't say to check, but those are equivalent. Chav, how do you know they're equivalent? So check this out. You guys ready? I know. You don't have to write this down. You can just listen. You see how this says 7 cosine theta minus 23? I'm going to come over here. I'm going to click y equals. You can just observe, guys. 7 cosine x minus 23. Okay. Now I'm going to go ahead and write the number that I had. What was the expression that I had, guys? 6.44. So help me out. 6.44353 cosine x plus, what was the y value? Or the, sorry, what was front of? 73511 sine x. Look at this. Check this out. It's going to go fast. Look at the blue. Look at the red. Window. Let's go 0 to 500. And let me make this by 90 degrees. And let's make, I already forgot what it was. I think that's fine. Negative 10 to 10. All right, graph. Look at that. Same graph, same curve. Isn't that cool? It went kind of fast, but you guys were able to see it, right? So we know they're the same. And there it is. And I know what you're thinking, like, Chav, what's the whole point? Sometimes it's easier to break up a cosine into two separate signals so you can analyze each signal separately. Sometimes you don't want two signals and you want one signal. And I think that's what we did in the fall semester. We took two signals and made it to one. And now we're going the other way around. We have one signal, we want two. For many different reasons. This is just the tip of the iceberg. You know, obviously the logic is what you're taking with you forever. But does that make sense, guys? See, and that's it. And that's it. That's it. We're done. Go to the next problem. This is just a review here. This one's a review from fall. Review from fall sem. Don't worry, Romero. We'll stop in a little bit. And I hope this isn't torture, is it? Okay. Hopefully you remember from the fall semester, it says use the linear combination of properties to solve certain trig equations algebraically. This is what we did, guys, in the fall. You might not remember, but we did this. So that -2, notice that, first of all, your arguments or your frequencies for both cosine and sine are together. So that means I can do a hack. Hopefully you remember that hack. That -2 is in front of the cosine, so that -2 is like an x. I'm going to put x in quotes because it's not really an x. That 3 is like a y because it's in front of the sine. Do you guys remember that? So if I want to solve this algebraically, there's no way you can solve it algebraically like this. You need to get it in either in terms of one cosine or one sine. And we don't know how to do it in one sine, but we know how to do it to one cosine. So how did we do it last time? Like this. Like you said, that's like an x, that's like a y. So I'm going to be in quadrant 2. I'm going to exaggerate quadrant 2. Here's my hack. -2, 3, point. There's my point, -2, 3. I connect it from the origin. That's hypotenuse, and I come down perpendicular to the x-axis. This is 2 or a -2. This is 3. I need to figure out this. I'm going to put the letter A, and I'm going to put a side note here because this is what we did in the fall semester. A cosine theta plus B sine theta, sometimes we say x in there, equals capital A cosine theta minus D, where capital A was the square root of A squared plus B squared, and D was arctan of B over A. I'm going to put check quadrant to get the right angle. Does that all look familiar to you guys? Okay. I don't want you to be a robot, so I could have just written this, but I want to show you that reference, so hopefully that triggers your previous memory. All right, so here we go. I'm going to say, what's my A? I'm going to go square root, and I'm going to put -2 squared plus 3 squared if you want to be technical with your negatives, but they go away anyways because you're squaring it. -2 squared is 4, 3 squared is 9, 9 plus 4. So put a 13. And now to get my angles, I'm in radian. So I first put it in radian mode. So here's my calculator in radian mode. So mode, and go back to radian. So I'm in radian mode. All right, so here we go. First, I find this angle, the theta r. So I'm going to write theta r equals arctan, hopefully you remember, 3 over 2. Notice that I didn't put a negative because your reference angles are never negative. So arctan of 3 over 2. So I'm going to go arctan of 3 over 2. And there it is, 0.98279. 0.98279. That's a radian. And then to get the angle that I really want, which is this one, that's the angle D, I'm going to have to go pi minus this guy. Does that sound familiar to you? Okay, so I'm subtracting my reference from pi. So I'm going to take my calculator. I'm going to go pi minus, and I'm just going to scroll up and push enter. And there it is, 2.15879. The more digits, the better. 2.15, I already forgot, short-term memory. 2.15879. 2.15879 if it's truncated. All right, here's my equation, guys. We haven't even solved the answer yet. This is just to replace that so you can solve it algebraically. So here's my equation. I'm going to write, what am I going to write? Square root of 13, that's my amplitude, cosine, parenthesis, and they use x instead of theta, so I'm going to use x. X minus this guy, 2.15879, close it, and that equals 2. That 2 is this 2. Now we can do what we've always done in the fall semester. I'm trying to solve for x. I'll slow down. I'm trying to solve for x, so I need to get rid of the square root of 13. So I do that by, there's a product. How do I get rid of the square root of 13? Yeah, divide. So I'm going to write cosine x minus 2.15879. Hang in with me, guys. Don't give up. Over square root of 13. Hopefully this looks familiar. Hopefully this is like, yeah, we've been doing that. We did that for a whole 3 weeks. How do I get rid of the cosine? It's up to the, you can say arc or you can say inverse. It doesn't matter which one. Yeah, arc cosine or inverse cosine. So what do that to both sides? X minus 2.15879 equals plus minus arc cosine of 2 over square root of 13, close it, plus 2 pi n. Because we're in radians on this one. Yes? Because remember, like cosine of pi over 6 is square root of 3 over 2, but cosine of negative pi over 6 is also square root of 3 over 2. That way we can get both equations at once. Or maybe you like degrees better. There's a side note. Cosine of 30 is square root of 3 over 2, but so is cosine of negative 30. Is also square root of 3 over 2. So we use the plus minus to get both my answers, to get both the 30 degrees and the negative 30 degrees. That's degrees, but if it were radians, to get both the pi over 6 and the negative pi over 6. No. For sine, you do pi minus. Cosine of pi over 6 is a half. Cosine of 5 pi over 6 is also a half. So pi minus pi over 6 gives you the 5 pi over 6. Because the calculator, no matter how many times you type arc sine of half on the calculator will never spit out 5 pi over 6. Hopefully that explanation made sense. Did it make sense? Or are you just telling me yes just so we can go on? Okay. All right, here we go, guys. You're almost done. You just move this guy right here. X equals 2.15879 plus minus arc cosine of 2 over square root of 13 plus 2 pi n. From here, we're going to get our two equations. I know, guys. Hang in with me. We're almost there. X1. Take the 2.15879 and add the arc cosine of 2 over square root of 13. So here it is. I'm going to take this number. So I scroll up. Enter. Plus second arc cosine. 2 divided by, with the square root of 13. And that's it. Just go that far. Enter. Oh, I put a parenthesis. Oh, it doesn't matter, I don't think. And there, oh, look, that looks like pi. 3.14. I bet you that is pi. Yeah, it's pi. It's just that it's rounding or cutting off somewhere, but it's pi. 3.1415. I'm just going to write it as 3.1415. Plus 2 pi n. X2. Take the plus. Instead of the plus, we're going to do the minus. So you're just going to scroll up to this guy, and then just change the plus to a minus. $1.17600. 1.1760 plus 2 pi n. Okay? We're done, guys. We're done. We're just getting all the answers between negative 2 pi and 2 pi. One answer is 1.1760. Another answer is pi. Can I just write pi? And that's it, because I can't add 2 pi. But we can go backwards. Another answer, if I take pi and I subtract 2 pi, negative pi. And whatever that minus 2 pi is. So I don't know. So let me take my calculator. And I'm going to scroll up. This one, minus 2 pi. Because remember the domain was between negative 2 pi and 2 pi. Negative 5.107. Negative 5.107. And those are my 4 answers, guys. Okay. I know, guys, this can be brutal, especially coming back from a long break. It says to check the solution graphically. So let's check the solution graphically. I'm just going to type this equation into y1. So take your calculator, go to y equals, Shout out to you guys who got calculators as Christmas gifts. I think that's so cool. I did the same thing when I was a little kid. I asked my parents for a calculator for Christmas. And I'm gonna type in the left side on y1 and the right side on y2. The 2 on y2. Negative 2 cosine plus 3. I think I can remember that. Negative 2 cosine x plus 3 sine x. And then just 2 on y2. And then I'm already in radian mode. I'm going to click on window. I'm going to go negative 2 pi, because that's my domain, between negative 2 pi and 2 pi. And x scale, you can go by 1. Let's see. A y min, y max, a square root of 16 is 4. So I'm going to go negative 4 to 4. I know it's square root of 13 or something like that, but square root of 4 to 4. All right, let's see. Graph. It's those answers right there. 1, 2, 3, 4. Let's find them. How do I find them? I just tell the calculator. Do you remember this, Romero? Second, how do I tell the calculator to tell me how to find? Second, calculate, and I use which one? Intersect. I push enter, enter. Look at this Yale person here being a boss. Okay, I'll stop. And look, guys, 1.176. Isn't that one of the answers? Yeah, and then look, I know this one over here is pi, and this one's here negative pi. I'm not interested in those two. Let me get the one way back there. That one should be negative 5.1. Second, calculate number 5, enter, enter, and then scroll all the way back there, guys. And then I'm going to push enter. And then look, intersection negative 5.107. There it is. That's the one. Isn't that cool? So do you see how this can be kind of cool? Or are you guys kind of like, eh? Okay. Don't worry, guys. That's it. That's as hard as it's going to get. If you're thinking like, man, we got to do another one. This, you're just going to apply what we just learned. All right. It says express 7 cosine theta 2 theta minus 120 degrees as a linear combination of cosine and sine. So that means they want to see it like this. A cosine theta plus B sine theta. This is what they want. This is what they want. Sorry that my handwriting is so bad. All right. Bracket the cosine 2 theta minus 120. This is like A. This is like B. Referencing what, Chav? I don't know what you're referencing. Cosine A minus B is equal to cosine A, cosine B, plus sine A, sine B. It's not too hard to memorize that. I think it's pretty easy once you do a few of them. So there it is. That's what I'm going to do. I'm going to go 7, bracket, and I'm just doing this on the right-hand side, guys. So the A is 2 theta and the B is 120. So I'm going to write cosine of what? 2 theta. Cosine of 120. Put a plus symbol. Sine of 2 theta. Well, yeah, I guess you can put it already if you want, but sine of 120. Try and go in this order, though. A, B, A, B. Cosine, cosine, sine, sine. Cosine A, cosine B, plus sine A, sine B. And there it is. And then we're just going to distribute that 7, and then put the cosine 120 first. So, all right, 7 cosine 120 degrees. Chav, why did I put the cosine 120 first? Because cosine 120 is an actual number. Cosine of 2 theta plus 7 sine of 120 degrees sine of 2 theta. We're okay? All right, here we go. 7 cosine 120. 7 parentheses. Do you remember what cosine of 120 is? Romero, do you remember? Positive or negative? Negative 1/2. Cosine 2 theta. This is why we take those unit circle quizzes, guys. Do you remember what sine of 120 is? There you go. Good job, guys. Look at you guys. On the first day of school, you guys were like, what? And now we're flying. Because you guys are Cardinals. You get it? Okay. And that's it, guys. We're done. Look, negative 7/2 cosine 2 theta plus 7 square root of 3 over 2 sine 2 theta. If you were to type this in the calculator and this in the calculator, they would be the same graphs. Make sure you're in degree mode, though, if you type them in. How do we feel? And there it is. We finished, guys. Should we check it real quick with a calculator? Just for kicks? Okay, let's check it real quick. So I'm going to change my calculator back to degree mode. I'm sorry that we keep changing it. Mode, degree. And here we go. I'm going to clear Y1. I'm going to clear Y2. And in Y1, I'm going to type in the original, which was 7 cosine 2x minus 120, right? Okay, and then in Y2, I'm going to type in negative 7 halves. Let me use my little fraction feature. Negative 7 halves cosine 2x plus, or was it minus? No, plus. My little fraction feature again. 7 square root of 3 over 2 sine 2x. And check it out. I'm going to go window. I'm in degree mode, guys. So I'm going to go negative 360 to 360. It just depends what I feel like sometimes. And then amplitude, I'm going to go negative 10 to 10. And graph. And voila, look at that. Same graph. Isn't that cool? Yeah, that's it, guys. And then we have a little activity for you, not delta. We have an activity, and hopefully that all made sense, and we're just practicing. All right, let me stop this here.